Okay, so I wanted to mention that someone suggested, and I thought it was a good idea. Also, besides sending you a Schoology message with the link to the video every time I make one, if I could include the link somewhere on our page, and I was thinking of in the folder, but I said, wait a minute, we do the weekly agenda. It's broken up by days. So if you notice, I added a lesson video and the link. So this is the link to the video for that day. Okay. So, right now I'm making this video, and for Friday, I'll put a new link there for that sometime today. Okay. So moving forward, that's what we'll be doing. So today, like I said, we're going to um, finish up the notes, and then we're going to continue learning about solving systems by graphing with an IXL, and we'll talk about that. So let's finish up the notes. Let's all go to um, notes and finish up this Cami. So if you're there already, open it up and let's begin. So I'd like you to start that now, please. Okay, so here we go. This is as far as we got. I'm going to zoom out so we can all see. All right. And we're going to continue and do the rest of these notes. So if you don't mind, let's begin. Okay. Um, let's zoom to 200 since I just want to focus on number 5. So everyone go to number 5. I'm just going to go around, make sure we are there. Remember, this is for points, so please make sure that you follow along. Um, get yourselves there in the next minute or so. All right, let's begin. All right, so the first thing we're going to do is we are going to graph y equals negative 2/3 x minus 5. Fortunately, this equation has y by itself. It's in slope-intercept form. I know the slope. I'll grab the markup tool to highlight that. The slope is negative 2/3. I know the y-intercept. It's negative 5. I have everything I need to graph. So let's do that. We're going to graph, go to negative 5. That's our y-intercept point right there. Then this is telling me to go down 2 spaces and to the right. We always go to the right if possible, because it should be a negative slope. It's going to go downhill left to right. And then just so I get more points, I'm going to go up 2 and to the left 3 to get this point. And I'll do that again to get that point. And I think that's as many as I can do. So we'll do that. Let's graph it. Go to shape. I'll make sure it's purple as well. And here's, oh, I got a circle instead. Let me erase that. And shape, I want line. Boom. Okay, so that's the first line. Our second equation, and on today's IXL, once you get closer to 80% on the SMART score, you're also going to have the same thing. You have equations that have to be rewritten in order to graph. So we got to do what we did yesterday. So let's start. Let's get rid of this negative 2x. Let's add 2x to both sides. So we got to do a little algebra. I'm going to grab my text tool, make sure it's on red here. And over here, I'm going to put plus 2x. Ooh, that's kind of big. Maybe 14 would be better. I'm going to change this to 14. Better. Okay. And on the other side of the equal sign, plus 2x also. We're just going to add 2x to both sides of the equation. Let me grab my drawing tool real quick to show that I canceled that. That's too thick. Change thickness. So we did all of that to cancel the negative 2x. Okay, so what do we have now? Yes. Say that again. 3y 2x. Always look at the signs in front. If there's a minus, a negative, make it minus. If it's there's nothing or a plus, it's a positive or addition. Okay. We have 3 in 3y. We got to just get rid of that 3. Let's divide by 3. So for this, I'm going to go back to my text tool. And underneath each term, I'm going to divide by 3. So I'm just going to locate a 3 underneath. So a 3 here, 3 there, 3 there. I'm going to cozy it on up and grab my drawing tool and draw 3 little division bars. Here, here, and here. Okay. All right. So I think this will be the last step because, since I got my drawing tool, let's cancel the 3's. Let's see what's left. We finally have y equals 2 divided by 3. So that doesn't divide evenly, so I'll leave it as a fraction 2/3. X. Negative 15 divided by 3, that does divide, so minus 5. Okay, so there you go. That's what we have now. I'll give you a moment to catch up. Yeah, they do actually, huh? Yeah, one's a negative slope, this one we just did, and the other one has also minus 5, same y-intercept. So that's where they're going to intersect. Good catch. Let's grab the drawing tool and make those points. So I'm going to go back to thickness 6, and at negative 5, they match up. So that's a solution point at 0, negative 5, but let's make the line. This one is up 2 over 3. Okay. And up 2 over 3. Okay. Just put one on this side as well. And let's make a line going this way. Uphill, left to right. Okay. So our solution is at 0, negative 5. Okay. All right. Any questions? Okay. Let's move on to number 6. With number 6, they're both already ready to graph. They're in slope intercept. Lucky us. Okay, so let's just graph those points. It's going to cross negative 2 and up 1 over 3. And we'll do that a few times. Okay. Got it. Let's draw this line. Now that we don't talk about Bruno songs stuck in my head. Okay, so for the second one, I'm going to write down what the slope and the y-intercept are because sometimes we forget. So the slope for the second line, yeah, it's a negative, so that's -1, which we write as -1/1. And the y-intercept, of course, is +2. So let's graph that. So it's at +2. And then we're going to go down 1 to the right 1. And I see already where it's going to cross right there at 3, -1. So I'm just going to put a few more points and then just graph that. Where are you? Oh. What happened? That was a first. Did you see what happened? It all just disappeared. I'll fix it right now on the... Okay, there we go. So the solution, oh my God, here we go again. And it's the attendance office, but I never get to go home. It's always a student. 30. Yeah, she's in my first grade. Oh wait, no, okay, yeah, you're right. No, she's not. No. Double check. Oh, yeah. Hold on. Let me check my roster. Oh, okay. Xiomara, yeah. You're going home. I'm sorry. You're here and Enriquez wasn't here. I'm sorry. You're going home. Yeah, sorry. I have also Xiomara. Yeah, Enriquez. Okay. Thank you. All right. I should pause this. Okay. So let's continue. What did we say our solution was? 3, -1. All right. Okay. Well, that's nice. They didn't have us rewrite too many of these. All right. So the next question, number 7, they're asking us to figure out when two lines are basically parallel. In other words, we have no solution without graphing. So it says constants graph a system of equations with no solution. If the first equation was y equals 6x minus 2, so let me just highlight a couple of things here. No solution. We're looking for no solution. And her equation was y equals 6x minus 2. They're asking us to circle the letter of the equation that could be the second equation in the system. Explain your choice. Okay, so these are our choices, A, B, and C. And what we're looking for, if we go back to the top, where we looked at the different types of possibilities, parallel lines is what we want. And that happens when you have the same slope and different y-intercepts. So we're looking for the same slope but different y-intercepts, okay? So going over here, we have to rewrite one to maybe all three of these equations until we figure out one that has a slope of what number? What's the slope have to be? What's the slope here? Yeah, 6 or 6 over 1. And also that the y-intercept part is not -2. It could be any number besides -2. Because if it's identical, then we fall into the infinitely many solutions category, because that's where the same slope and same y-intercept, and we don't want that. So we want something with a slope of 6, so 6x plus or minus something other than 2. Okay? Or, well, something other than -2. Well, hopefully, yeah. Let's try the first one. So what we're going to do is we're going to use our workspace here to do that. Type in that first equation, -24x plus 4y equals 8. We don't know what this is going to look like until we rewrite it. And that's what we're going to have to do. Okay, so starting with this one, let's see. Well, we have to rewrite it, get rid of -24x. So our second step is we're going to divide by positive 24x, okay? So step 2, plus 24x. Oh, I'm going to do this in red. Okay. And on the other side, do the same thing. Okay. So that's our first step. Let's grab our drawing tool, change the thickness to 1 because I'm just going to use it to draw a line, and cancel this. And I'm going to retype what I have now, which is 4y equals 24x plus 8. Okay. So I'm liking this equation right now. You'll see why. Mm-hmm. Yeah, and that's what we have to do, right? We have to divide by 4. So I'm just going to show division by 4 by putting a 4 underneath each term, because everything has to be divided by 4 to cancel out the 4 on the left. So let's do that. And more importantly, we're also not going to get -2. Okay, so let's do that. I'm going to draw a little division bar here, here, and here, and cancel this one. Okay. So y equals 4 divided by 4 is 6x plus 2. Huh, I like it, because, let me highlight it. Same slope, different y-intercept, which would make those parallel lines, so no solution. So our answer, since they asked for it, let me grab the shape tool, is this one. We got it on the first one, thank goodness. So let's type up why this is true. The two lines are parallel. I'm just going to say the lines are parallel because they have the same slope and different y-intercepts. So, no solution. Okay. Okay. So you ready for the last one? You guys ready? Let's do it. So Jude's water balloon is empty, but filling up at a rate of 5 milliliters per second. Ian's water balloon contains 45 milliliters of water and is losing 10 milliliters of water per second. Okay. Write an equation to represent y, the amount of water. Let me highlight that because that's important. Y represents the amount of water in each balloon based on x, the number of seconds. So we're going to come up with two equations from this, okay? One for Jude, and it says a Jude's balloon is just filling up at a rate of 5 milliliters per second. So let's write an equation starting with y, the amount of water, equals 5 milliliters times x, the amount of seconds. That's it. That's the equation for Jude. Ian's is going to be different, right? Oh, let me put an equal sign. Y equals, we could write it as 45 minus 10x. I'm going to flip those around though, because I'm used to seeing it with the x term first. Negative 10x, because it's going down 10 milliliters, times the number of seconds, plus the 45 milliliters that it started with. So all I did was flip that, right? But that's basically the same thing that Santiago just told us. All right, so we got our equations, and that was pretty easy. So let's just graph them. Let's start with Jude. Go back up to 6 for the thickness. And hers is going to be starting at 0 because there was no water at the beginning. Then every second there's 5 milliliters more. And this is increasing by 5 milliliters at a time. So this is just a diagonal like that. Okay, so let me just graph that. Make sure it's a line. And this is just diagonal right there. Like that. So that's describing how Jude's water bottle is filling up. let's go to Ian. Ian's a different story. So for Ian, where are we going to start? At 45. So he started with 45, but his is going to go down 10 milliliters every second. So you go down 10 over 1 second, down 10 over 1 second. And right there is what we would call the solution. So, so for Ian here, it's going to go like this. And somewhere between 4 and 5 seconds, no more water in the balloon. Okay. But yeah, we did have an intersection point right here. At 3 seconds, it's 15 milliliters. Right? So we just graph the equations, and it says, what is the solution of the system of equations, and what does it mean in the context of the situation? So what happens at 3 seconds that it's, yeah, they have the same amount of water. One's increasing and they hit 15 and the other one was decreasing. So at 3 seconds, they both had 15 milliliters of water. Okay, let's write that down. At 3 seconds, both balloons had 15 milliliters of water. Okay? So if you got this far, you got everything we did, then congratulations. You have everything you need. Make sure you go to turn in, press turn in, and submit it. And that's it for this assignment, or for the notes, I should say. I'll be making copies digitally, and I'll put it in the notebook for you, so you'll have them in the digital notebook. But yeah, these are the notes on systems. Yes. If it's not done, we're going to do something. I just want to do something, show everyone what the next assignment is, so everyone that is done can get started, and then I can show you the parts that you're missing so you can catch up, okay? All right, so give me a second. What I'd like you to do is follow along with me here. You don't need to do it yourself necessarily. I just want to show you. So this is the IXL. Again, you got to get a 90 on this to get full credit. So it's basically what we did on the delta. It's a little different, so I want to help you with that. The further along you get, you are going to have to rewrite one or both of the equations into standard form. So that's going to happen once you get into like the 60s, 70s, or 80s. But basically, you look at the line, you do the first line, it's in orange. So I go here, this y-intercept is 1. That's your first point. You go down 1 over 1. There you go. Then I have to do the second point. To do the second line, rather, click the green. And then the y-intercept's -1. The slope is -5 over 3. Okay. Graph your line and take a look. If it doesn't cross somewhere perfectly, you probably made a mistake with one or both of your lines. Double check your work. This one looks good because it's crossing at -3, 4. So down here, I'm going to type -3 and then 4. and you would submit that, and you're on your way. Okay. So that's basically what the assignment is for the IXL.